In this lesson, I'm going to go over the options that we have for rendering our particle simulations. As I mentioned before, the Sprite Renderer, which is the default output for our particles, is representing the particles as a 2D flat surface, meaning that we only have X and Y coordinate system for the sprites. They're always facing to the camera, which is most of the time perfect for our particle simulations because most of the time we want to have the particles to only represent a 2D space. So a 2D Sprite Renderer is a perfect option for our particles. So the next option that we have is that we can have these particles to act as a light source, so they emit some lights in the scene. Keep in mind that this option is only visible when you put your Niagara system in a scene. So when you want to see the results, you have to always switch between your Niagara system and your layout to be able to see the results when you're changing the parameters. Let's get into that. So I'm going to add a new render module here from scratch. So I'm going to click on this plus sign and I'm going to choose the light renderer. As you can see, for this renderer subcategory, we do not have those many modules that we used to have for the other parts. We are only dealing with the render options that are available to us. So I'm going to choose the light renderer. Please ignore this one. I just turned it off, so we won't deal with that at all. Let's get into the light renderer. Not too many options. So for the light renderer, we have radius, which represents the size of the light that is attached to each one of these particles, and also we have the option of changing the color of those lights as well. So it's an RGB value, although it says XYZ, this is actually representing the RGB values for the color of the light. Let's just turn off the Sprite Renderer for a moment so we can just focus on the lights. I'm going to switch to the layout and you're going to notice that lights are not showing up. That's only because the values that we have for the radius as well as the colors are very low. So let's increase the scale, the radius scale of the lights to something larger than that. Let's get into 20. And for the color, I'm going to choose a pure red color. So I'm going to type in 1 and let's see if it shows up here. Still no luck. So still it means that we need more intensity here. In this case, we do not have that light intensity. So the light intensity is incorporated into this color value here itself. So if I want to increase the light intensity, I just need to have larger values for my color input. It will act as the intensity of the light as well. So let's increase that to 50. And you notice that now I'm seeing the results in my scene. These are the particles that are showing up. I'm going to go back and modify some of the attributes even more. So let's increase the intensity to 100. And I'm going to increase the radius to something larger than that. Here we go. Right now, my particles are only rendered as light sources, which means that I'm not able to see the source, but only I'm seeing the result on the lights that they're casting on this geometry. So if I do want to see the particles themselves, I just need to turn on the Sprite Renderer as well. So now I'm generating particles that are being represented by the Sprite Renderer as well as the light renderer. So not only I'm going to see the particles, but also I'm going to see their lights, the lights that they're casting on the geometry too. Here we go. And you can see that I'm having individual control over the color of the particles and the color of the light. So I can have particles to represent one color and their light source to have another color. So they're totally independent from each other and I can change them individually. I'm going to go back and give it some green color as well. It might become a little bit more orangish and I'm going to increase the intensity of the red. Okay, so this is one option that we have for rendering our particles. The next option that we have is a mesh renderer. So I'm going to turn off this first emitter and I'm going to turn on the other one. All right, so for this one, you can see that I'm having a nice orbit of different rocks. Let's see how I created that. What I have here is a torus location. So this is going to be my emitter. I have a point attraction force to pull these rocks towards the center, because as soon as I add the vortex force, it tends to actually push these rocks away from the center. So I decided to have this point attraction force here to let them stay in the place. In the particle update, I'm having a curl noise, so it's only creating some random movement on these particles. I have a drag to hold these pieces together and let them lose some energy so they don't again get out of control. I have a vertex force which is along the z-axis with some medium amount on its scale, and I'm also having a color here, which I'm going to talk about how we can use colors and textures on the same mesh at the same time. So I'm using a mesh renderer. Let's go over that and see what we have there. I'm going to again start from scratch, mesh renderer. So for mesh renderer, we are creating this module to be able to assign a mesh, assign a geometry to our particles. We can create our own mesh inside any 3D application, and we can use them to represent our particles. What I have done here, I went to Maya, I've created this random geometry, then you just need to export them as FBX format. I've already exported that and named it rock. Then inside of Niagara, you will import that. So you will go to Niagara, right click, import to game, and import your geometry. You can just hit import. You can ignore all of these options. Then when you have that geometry in your Niagara system, on your emitter, on your mesh renderer, you should be able to find your geometry from this drop-down list. Rock geometry. Now I'm seeing my geometry showing up. Perfect. And for the scale of these particles, I decided to make them non-uniform and random to have some more variations on their size and their scale. So I decided to have a random non-uniform for the scale of the mesh. And this is the place that I skipped in the first lessons when we were working with the sprites. Now that we are using meshes as our renderer, you need to change the values on the mesh attributes rather than the sprite attribute. This is one place that you have to be careful about that. The other place is when you are trying to scale your particles over time. We used a scale sprite module. This scale sprite size doesn't work on mesh renderer. So rather than using that one, you need to create a scale mesh size. So now my mesh is going from 0 all the way to full size, whatever it is, maintaining that size and then scaling down. And other than that, it's done, except for the fact that our meshes do not have any material on them. So in order to take care of that, on your mesh renderer, we already assigned the geometry. We also need to assign a material to them. So I need to enable the override material and click on this plus sign to add an element. This allows me to add my own material and override whatever I had on my mesh. So I'm going to create a very simple material for my rocks. Right click, create a material, and I'm going to name this my rock material. Double click on that. I'm going to just make it very simple. I can push down 3 and left click my mouse to create a color parameter, and I can choose any color and I can connect it to my base color. Let's just start with that one. You have to save your material to be able to see the results in your scene. All right, so I'm going to go to my mesh renderer and I'm going to assign the new material that I have just created, my rock material. Give it some time to compile the material, and now you can see the result. Just to make it more interesting, I'm going to assign a texture to this. So I'm going to go back to my material. I'm going to create a texture sample. Since I also included the starter content, I have some materials that I can use here. So I'm going to click on this and I'm going to type in noise. I'm going to use a Perlin noise and I'm going to connect it to the base color. Save, give it some time. And now these geometries are having some texture on them. There's one thing left for rendering out meshes as particles. The problem with assigning material to our meshes is that now the color and the brightness and the specularity and everything of these geometries, these meshes, are coming from that material. Which means that if I have a color module, and even nicer if we have some random colors on our particles, we will miss them now because that mesh renderer with that material on it is overriding any other color that we had on our particles. We need to somehow incorporate this color information into our material. Where we created the material, the rock material, we had a texture, and in our Niagara system, that texture is being read by the mesh renderer, and we need to somehow, again, have access to this color in the material so we can use whatever we had as a color of our particles, including randomness, including opacity, anything that we had, to be able to affect the material itself. We do have a node in the material editor that allows us to have access to the particle colors, and the name of that node is particle color. It has the RGB values as well as the alpha values. Let's say I want to keep the same texture, but I want to have them colored by this random color. So I can simply multiply. I'm hitting tab, by the way, on my keyboard, or right click. And I want to multiply the texture to the color of the particles and then use that for my base color. That's the first step. Let's save that. And I'm going to go back to my scene, let it compile. And now you can see that I'm still having that texture with some random color that comes from the color of the particles. So now if I change these, I can change my texture's color without even going back to my material editor. I can even use the opacity. Let's go back to my Niagara system, and I'm going to use a new color node, and I'm going to disable the previous one because this time I want to use a curve over time. So curve, color from curve. I want to start with a red color, perhaps go all the way to yellow. And what this time I want to try is playing with this opacity. So I'm going to add a key here, and I want to start with an opacity of 0. Maintain the opacity, and then go back to opacity of 0. All right. If I go back to my material, I am using the color already. I want to use the opacity as well. So I'm going to maybe even directly connect the opacity of the particles to the opacity of my material. I'm going to change the type of my material to translucent. So I have opacity, and I'm going to use the particle opacity to the opacity of my material. Save. And then go back here. Now this opacity is going to affect my particles. You can see that when they're born and when they are disappearing, their opacity gradually goes to 0 or 0 to 1. So I do have access to that opacity in the material editor now. All right, the next option that I wanted to talk about when we're dealing with particles and textures is using sub-UV textures. I'm having a very simple emitter that is generating particles, and I'm having some forces, and these particles are scaling up and down. First of all, these are all sprites, so there is no geometry used here. And rather than using the default sprite material that comes with Unreal, we can assign our own textures, our own materials to these sprites as well. So what I have done here is I have created a material myself inside the material editor, and then I assigned that material to this particle system. Let's see how I have created this one. I'm going to turn off this one, and I'm going to start from scratch. I'm going to create a Sprite Renderer to start with. I'm going to just show you what we have by default sprite material. This is what we get by default, and this is a very simple emitter. Let's get into Photoshop, and I'm going to create a new texture. I will make sure that I also have some transparency. So let's start with a simple thing. Let's just draw something here. And I'm going to save this as a PNG format or a TIFF format so I can have the transparency with it. Cross. The next step is to import this texture into Unreal. So I'm going to go to my content browser. I can just drag it and drop it here. Okay, so we have the texture. So I'm going to create a new material. Cross. Inside of that material, I'm going to create a texture node, and I'm going to read the cross texture that I've just imported. Since it has transparency, I need to take care of the RGB as well as I need to take care of the transparency. So I need to connect this to the opacity, but the opacity here is grayed out. I need to convert that to masked type, where I can use my alpha channel, and now it's supposed to show up as a cross with alpha channel on it. Let's save that. And here on my sprite renderer, I'm going to use my cross material that I've just created. Let's go back to our scene. Here are our sprites. Again, going back to our case here, we want to be able to have multiple textures for our sprites. This is called sub-UV texture. So we have a UV that can hold multiple sub UVs in it, and each one of those sub UVs can hold one shape. And then later in the sprite renderer, we can randomly pick from those sub UV textures. Okay, so let's go back to Photoshop. I've already created this series of textures, and I split that into a 2x2 grid. So in this case, I only have 4 shapes for my textures. And since we do have transparency, we need to save it as a PNG format. I've already done that. I'm going to go to Unreal. And inside of Unreal, I'm going to import the texture. Create a new material. My leaves. Okay. Let's open it up. And similar to before, I'm going to create a texture sampler node here. Read my leaves. Right here. And let's just start by connecting the RGB to the base color and the alpha channel to the mask there. Alpha opacity mask. Let's save this. And here for the texture, I'm going to assign my leaves. So things are working similar to before. But again, the problem here is that right now each one of these particles are having all of those 4 sub UVs there. And in order to read these sub UVs, we need to go to 2 places to be able to define the size of those grids. The first one is going to the sprite renderer itself and find the tab that says sub UV. And right here, you can see that the sub image size is set to 1x1 by default. In our case right now, we are dealing with a 2x2 grid. So here I need to type in a 2x2 grid. That's the first step. It solved the issue. Right now it's loading one of the sub UVs. That's perfect. But we need to make sure that we can pick the rest of them as well. We need to add a new module in our particle spawn to be able to sample each one of those from that 2x2 grid. So that module is called sub UV animation. Keep in mind that I'm adding that in the particle spawn because we only need to sample that once when the particles are being generated and not more than that. Where it says sub UV animation mode, I will change it to random because I want to randomly pick from those 2x2 grids. And it says start frame and end frame. This represents 1, 2, 3, 4 frames. Okay, so it will treat each one of these as a frame, and it says what's the number of the first frame, what's the number of the last frame. So I will define them right there in the start frame and end frame. Keep in mind that the start frame starts from 0, 0, 1, 2, 3. So the last frame is set to 3. And now this random number is always something between 0 and 3, and it will assign each one of these textures to them randomly. And the rest is just a particle simulation. There is one more option that comes with the sub UVs that allow us to even get deeper into these textures and have some animation and some organic animation on these textures too. Let me turn this off and turn on the next example here. We are going to get to something like this. So here I'm creating these smoke effects. Let me get into the layout itself so we can have more contrast so you can see more of the texture. And I'm going to turn down the number of particles here so we can focus on less number of particles so you can see the textures and how the textures are actually working. If you notice there, these clouds, not only they're having different sizes, different opacities, but also they're animated. This is all through the same method of sub UVs. So this cloud is texture with 8x8 grid for its sub UVs. If I open that up, I'm actually using the default texture that comes with the starter content. It's called smoke sub UV. This is the texture that is being used in this case. So let me double click on that. This is exactly the same concept. It's a sequence of deformed smokes over time, and it's an 8x8 grid. It also comes with a pre-made material. So you don't even need to create the material for it. You just need to search for a smoke. In the starter content, there is a material with the same texture, which is called M smoke sub UV. On the particles, we still have that sub UV, which is this time 8x8. Perfect. On our particle emitter, this time we are not sampling each one of those particles once and just get away with them. We need to update that. So this time, rather than having the sub UV animation in the particle spawn, which we used for the leaves, We wanted to sample them only once, right at frame 0. So we put that in the particle spawn. But in the cloud simulations, for each one of the particles, we want to go through those series of textures and rate them one by one to make a sort of animation out of them. And rather than randomly picking from those frames, we want to linearly go from frame 0 all the way to frame 63, which is in total 64 sub-UVs. There is one thing that we still need to do for these cases when we are going through a series of textures. We have a checkbox here on the Sprite Renderer that allows us to blend between each one of these consequent frames. It will make that animation to look very smooth because it will generate the in-between frames for us. And that's the sub-UV blending enabled. Cool. Before wrapping up this lesson, I want to talk about some post-processing on the particles because it will allow us to make some good-looking particles at the end as well. All right, we are back to our first original particle system. We have lights, we have sprites. One thing that I'm missing here is some glow effect on these particles. So inside of Unreal, we have a node called post-process, which is found under visual effects. Post-process volume, I can even type that name here, post-process. And I'm going to drag it into my scene. So what this post-process cube does is that whatever that is inside this cube is going to be affected by any effect that I add to this post-process. If you're coming from After Effects, this is similar to adjustment layers. Adjustment layers we used to have on top of our composite. And we could add any effect to that adjustment layer that would affect everything underneath that. It's the same thing in Unreal using this post-process volume. Anything that is sitting inside this cube is going to receive any kind of post-process effect that we add to this post-process volume. One thing about this post-process volume is that I can scale it up, or there is a checkbox on this post-process volume that I can turn on and it will have it to affect everything in the scene. So it's going to be indefinitely affecting the entire scene. And that is called extent, infinite extent, or unbound. I'm going to turn it on. And now all the special effects that I enable on this, it's going to affect the entire scene. So let's delete that filter. And I'm looking for bloom. And I'm going to turn it on. And turn the intensity on. And I'm going to turn that on to a value of 2 or 3. You might see some blooms showing up on these particles. That's because of this post-process effect. So let's increase that and see what we get. The point here is that these colors that we have on these particles are not that strong to be able to generate some glow effect. If I go back to my particles, if I go to the colors of these sprites, colors, here we go. It's set to color of white. If I click on that, we will see the RGB values as well as the HSV values. So hue, saturation, value. Hue is the color, saturation is how intense the color is. And also we have the value. We tend to have these HSV values within the limit of their maximum and minimum. For example, for the value, we always have the value to go from 0 to 1. However, in high dynamic range setups, this value can go even beyond the maximum value of 1. I can type in a value very high here, for example, 50. While I'm having the same color and hue and saturation, the value this time is 50. I won't see that unless I go back to my scene. And now my post-process effect is going to show up even more because now the values are very higher than previously what I had. The glow is perfect. However, I'm getting these lens flare effects as well. Let's find that lens flare effect. Lens flare. And turn it down a bit. By default, its value is 1. If I want to change that, I need to enable this and then type a value that is way lower than what I already had by default. So now what I'm seeing here is mostly coming from the bloom effect, the glow effect. And it's being changed whenever I change this value of the colors, whatever color I have on my particles. If I go to the HSV mode and increase the value, I will get some very nice looking glow effect on my particles. So let's just change the hue and saturation. Hit OK. Go back here and now you can see how the glow effect is showing up on my particles. Okay, we can wrap up this lesson. In the next lesson, I'm going to talk about some leftover materials.